Welcome to solverfy.
All right, for this problem, we want to answer the question, how many partial functions are there from a set with 5 elements to a set with blank elements, where blank will have a different value for each part? So before we actually jump into evaluating anything, I want to point out this partial function thing. So essentially, a partial function is a function where no result is a possible result. You have your domain, you have your codomain, and it's possible to have something in the domain which does not map to anything in the codomain. For instance, if we think of -1 and 1, and we are mapping from that domain into a new domain, whatever's in there, using the square root function, well, -1 doesn't, or actually, I'll be a little bit more specific here. Let's say we're mapping from -1 and 1 to the set just 1. Well, -1 doesn't map to anything in the codomain. You have an undefined result, whereas 1 does map to something in the codomain. So essentially what that means is that even if there's only one possible element in the codomain, if you have a partial function, then you actually have two different possibilities. You either map to the one element in the codomain, or you map to nothing. So in the first question here, we are going to be mapping from a set with 5 elements to a set with 1 element. So this is going to be a problem where we can apply the product rule. Essentially, we can think of it as we have a series of tasks. In fact, we're going to have 5 tasks. And for each one of those tasks, we have, in this case, let me back up here. We have a series of tasks, those tasks being to assign an element from the codomain to something in the domain. If we have one element in the codomain and it's a partial function, that means that we have 2 different ways of accomplishing each task. That means that for part A, the number is going to be 2 to the power of 5. We have 5 tasks, 2 different ways of going about it, 2 to the power of 5, so we'll have 32 different possible functions. For part B, the number is 2, so this is going to be 3 to the power of 5. You can either have no result, 1 or 2. So 3 different possibilities. So we'll have 3 to the power of 5 different possible functions, and 3 to the power of 5 is 243. Continuing on for part C, we have 5 different elements in the codomain. So we'll have 5 to the power of 5, which, 6 to the power of 5, because there's always that null result. So we'll have 7,776. And then for part D, we have 9 different elements in the codomain. So we'll have 10 to the power of 5 different possible functions, or 100,000 different functions.